Hello and welcome back to the channel. This is the second episode of our work to recreate Battle City in Godot 4. As you can see, I'm right now using 4.4.4 stable. So if you're not at that version, I recommend that you update to the latest stable. And this is where we left off, which isn't really much. We have a camera, we have a tile map layer, and we have some additional script that's gonna work as a game manager. So I believe this is the right point in our development to add a player. So let's go to scene, new scene, choose other node, and we'll search for area 2D. With that, I will rename that to player and add the basic node that we need, which is the sprite 2D. And then we will also need a collision shape. So let's grab that and let's set our sprite first. So go to sprite and then in inspector, I would just grab this and drop the battle city. As you can see, this is of course a little bit too much, but we can limit the things that we're displaying for a player by enabling region and editing it. I will choose the snap and I will snap to pixel, and let's grab this for now, and we'll adjust the width because it should be 16 by 16, of course, but maybe can we just make sure that this is in the middle if it's not. So let's do grid snap instead, and let's do 2 by 2. And let me, okay, and with that we can update it to the proper values so that it is in the middle. So it should be 13 by 13, and now it's in the middle. The sprite itself doesn't really matter. What matters is the collision shape. So we can go, you can take a look at those values again. This is x1, y2, width and height are set to 13 because the sprite itself is actually smaller than the grid size, which is, in our case, we'll be working with 8 by 8, but actually 2 times of that, like 16 by 16. So for the collision shape, I will of course add a simple rectangle shape, and this time I'm gonna put this to be 16 by 16. And we can go to scenes and save our player. Okay. For now, there's not going to be anything interesting going on, but we can place our player already. So instantiate child scene and choose the player. And let me put it right here, or maybe even in the middle here. Let's check the transform and round it up. Okay. Remember, we're working with the multiples of 8, so minus 8 by minus 24 should be good. Okay, moving on, I would like to make it move. So to do that, I'm going to create new script. Let's move it to the scripts folder. Player is fine. Okay, so with that, we can actually start working here. With few things here. One is of course the speed, which we can manipulate. So this is 25. We need the reference to sprite. So control drop it to get that reference. And I believe that's it for now. We will need to start the velocity. So let's create a variable for that. And we need to set up our inputs. That's also rather simple. Going to project settings, and we'll just do, oops, this is up, not uppo. Down, left, and right, and we can already add shoot. So that's going to be W, S, A, oops, A, and D, and space for shooting. So this is our input map for now. Moving on, I would like to make our tank actually move. So we will need to read the input. So let's create a simple function here, and that's one gonna get called get input, and it should return vector2. So we'll just simply process the input. We'll assume that it starts at 0. If input is action pressed right, actually we don't need that variable. We can be smart about it. We can just return early. So return vector2, sorry, right. If input is action pressed left. Is action pressed up, return up, and then return vector2 0. And that's all we need from here. Okay, so that's that. And then we need just to apply this. We can do it in physics process. So the input is equal to get input. If there's no input, we'll just return. Then what we need to do is actually is to update the rotation of the tank, right? Because if we're going left, right, the tank is rotated by minus p divided by 2. That would be 0 rotation. Then we have pi divided by 2, and then of course pi, right? And we're working with a radians here. You know, in terms of degrees, that would be again 0, 90, 180, and minus 90. But that's basic math. You should probably know that. Or at least I hope you do know that. So let's update tank rotation based on input vector. Okay, let's write that function. Input vector. Let me get some space here. Input vector is supposed to be of type vector2, and that function should return nothing, so it's void. Yeah, let's do just that. If input vector is equal to vector2, right, the rotation of our node should be set to pi 2. Else, if input vector is equal to vector2 down, the rotation has to be pi. Else, if input vector is equal to vector2 left, oh, we need that one here. I mean, input vector is equal to vector2 up, rotation should be set to 0. And let's see how that works for us. Yeah, I can see that the tank is rotating correctly. So that's cool. Let's actually make it move. So this is going to be rather simple. We can calculate the velocity as input vector times speed times delta. And we can just say that the previous, that the position is equal to velocity. And now we will be moving. The problem is that we're not colliding with the tiles, right? And there are many ways to handle that, but let me explain one thing about movement in Battle City, which is going to heavily influence how we're doing collisions and how we are moving our tank. So if this is our grid, you know, like a crossroad between grid tiles, if we have a tank that is moving, it has a snapping added to its movement, meaning in normal circumstances, since we are working in 16 by 16 grid, you could only turn at the crossroad if you're perfectly at the center of it. But that's not the case when it comes to Battle City and movement. The player has its life made easier because there's a snapping enabled, meaning that he doesn't have to be in a perfect position to be able to turn perfectly in a crossroad, right? There's a snapping enabled, and there's a tolerance to the snapping of how much of the tank has to be like off the grid or not in the center to be able to turn. You can play this online, and once you try playing and really looking into the controls, you'll like feel it, right? So the game helps you actually turn left and right and change directions when going around corners, right? Because the game is detecting how close to a crossroad you are and whether you can actually perfectly turn into the different direction. So we actually have to implement that, right? So how to do this snapping? Let's start by actually going to project settings, and we need to set the proper layers. So project settings, general, let's search for layers, and here we will have tank, we'll have brick or grid, however you like to call it, and then I will also add a bullet. Okay, given that we have that already, we need to actually see the collision shapes. So if I go to visible collision shapes in debug and turn that on and run the game, I will see that the only thing that has a collision shape is our tank. So it's time to add the collision shapes to our grid. So go to tile map layer, tile set, and what we need to do is go to paint section, and in inspector editor for our tile map layer, go to physics layer and add physics layer. And we would like that layer to be to exist as a brick layer and be able to collide with tank and bullet. Perfect. And now I can go to my paint and select a property editor, and physics now have physics layer 0, which I can click, and I can then just paint the tiles that I know that the player should be able to collide with. So definitely those two. And if I will run my game again, I can see that now all of the tiles also have collision shapes, but this is not yet set to colliding. This is due to the fact that we're actually using area 2D instead of the character body. So we would like to manage our collisions manually. And this is mainly due to the fact that, as I said, we want that snapping enabled. Okay? So we need to actually change our tank node a little bit. So let's go into our tank node, and we will add a few things here. To handle the collisions, we'll use raycasts, and to keep everything nice and tidy, I will group those under node 2Ds. And why I would like to keep those grouped in node 2Ds is because I will treat those node 2Ds as a folders for our raycasts, and I have to use node 2D because those raycasts, they have to actually follow our player. So the plan here is to have our tank and have a set of raycasts, 3 in the front and then 2 to the sides. These ones will help us detect the front collision with any kind of obstacle, and then these ones will work for snapping. Okay, so let's set them with the proper starting values. I'll create Node2D, as I said, and I would say raycasts, and inside I will add another group, call this front raycasts, and then we also need left, and as you can probably guess it, right. Let's add raycast2D, and as I said, we will need 3. Let's call this one, the first one, center raycast, then left raycast, and then right raycast. And we need to set them properly. So first thing is the collision masks for all 3 of them should be detecting the grid. So let's select 2. Then we need the starting positions for those. So let's set transformation. This one is going to be 1 and 1. Or sorry, 0, 0. And then the target position is what interests me the most. As you can see right now, it's going way down and in the wrong direction. So the target position should be -8. And as you can see, it's in front of us, right to the edge of the collision shape. For the left raycast, we will do position set to, where is it? Position -6 and also -8. And to keep it symmetrical, of course, the right one should have 6 and -8. And to keep it simple, I can always favorite the property to see the transform at the top, which is really, really cool. So these are our front raycasts, and let's handle those now. So what I will do is I will go to the script, and I can create front raycasts array, and I can create those already. So front raycasts, and the type is array of raycast2D. And what I can do is just grab every single node path here. So this is how you can group your nodes in code. And now I can check just to show you those when you're running the game. They are populated properly. So here's our array of raycasts. Okay. So now after we update tank rotation, we can calculate is front colliding. So this is very simple. I can just say front raycasts any, and I can just write a function here, raycast return raycast is colliding, right? So I can just create an anonymous function to check if any of the raycasts from that array is colliding with anything. And I can just say if is from colliding, return, do not apply the velocity. And see how it works. Well, we're not moving at all, so not good. And this is probably because I'm using the reference to a function instead of just calling it. Right now, it is working really good. As you can see, if we are colliding, that means we're not moving. So this is our simple collision. The problem is that with the snapping, if I am standing here, I should be able to be snapped to the correct position right about here. Or if I'm here, I should be able to be snapped here, just to make turning easier. And we'll make that feature optional and turn it on and off with a flag. And if you don't like it, you can just disable it with one click. So let's export var enable snapping and set this to true by default. But again, if you don't like it, you can just disable it. And to make it work, we need to add the proper raycasts to left and right side of our node. So add child node raycast 2D, and I will call this left. Oops. Sorry for that. Left side and raycast. Duplicate this and call this left side start raycast. Both should be in the second layer. Then we need to set the position for both. So this is 3 and 7, and the target position is 5 and 0. So is this the left side? This is the right side, sorry. So -5 and -3. And now this is the left side. Correct. And this is end because it's at the end of the tank. And then here we need to set this to -3 and -3 and -7. And the target is -5. Sorry, -5 here, of course. So this is left side start raycast. And now we need to repeat this very same process for the right side. So right side end raycast and right side start raycast. And again, that should be 3 and 7, and the target position should be 5 and 0. And you can play with those values to influence how snapping behaves. And this should be 3 and -7, and the target should be 0 and 5. Perfect. So we have those set up properly, and I believe they should work. And yeah, and they do, as you can see, register the collision. So this is all good. So going back to our code, we can also group the right side and left side. So already right side, right raycasts. This is array of raycast D, and I can just grab the paths, and then I can do left raycasts. It's plural. Raycast D. And we can just drop left. Okay. So we have like pretty much everything. So we have our position set, and then what we will also need is to start the previous direction, and you will see why. The previous direction is going to be, we'll start our vector to 0, and I will say that previous direction, and I shouldn't use camel case, there is no reason for it. Previous direction is input vector. And here we will handle snapping, but only if enable snapping is set to true. So we need to calculate is left side colliding, and I can do that by saying left raycasts any, and can recreate the very same function. So since we are recreating these functions again and again, we can just create a new function to reuse it. And I can say is raycast colliding, and I will say raycast to D, return raycast is colliding. This is very, very simple function that basically does nothing other than calling that, but I can omit the repetition by just saying how did we call this? Is raycast colliding? Yeah, okay. Is raycast colliding? And I can reuse it right here. So now these two are using the very same function, and it is way shorter. And again, we'll use it one more time. Is right side colliding is equal to right raycast any is raycast colliding. Remember, we do not call the function, we just pass the reference here. Okay, and if it does, we'll just apply snapping. So we'll need to pass an input vector is front colliding, and then we'll also need to pass is left side colliding or is right side colliding. So whether we have collision on left or right side at all. Okay, and with that, we can write our apply snapping function. So apply snapping, it gets input vector which is vector 2, is front colliding, which is Boolean, is side colliding, which is also Boolean. And first thing we need to do is get 3 and wait 1 frame to avoid the off collision by 1. And if input vector y is not equal to 0, and it's not true that front colliding and is side colliding, we will adjust the position to be position snapped to vector 2 of let's see, our tile size is actually, oh, let's see, it's 8 based on our tile set. Yes, it's 8. Okay, so we can go here and just create a quick variable which is going to be 8, and I can just say that this is going to be, since we're moving in y direction, we need to snap to x. Else, if input vector x is not equal to 0, and it's not true that front colliding and is side colliding, position is equal to position snapped 0 and 8, meaning we should use the tile size, of course. And that should be protected. And I believe that's it. Let's see how this behaves, and if at all. We're calling this, okay. So I'm moving, and right about here, as you can see, I'm pressing the key once, and I moved into the center. Right, I am here, and I am snapping correctly. So if you compare this with the situation where the snapping is disabled, if I am here, right, I'm not being snapped to the center and I cannot move any further, right? So that requires us to be very precise in our movement. It's really up to you to decide which type of movement you would like to see. But to be honest, let's turn this on again. Often in retro games, in grid based movement, you will see this sort of snapping being turned on just to make sure that it is easier for a player to move around. Here, I don't have anything, so it does not trigger, but here, as you can see, it should. Again, we might have some edge cases here, but I'm not gonna bother with them because it's already too long. Like, for example, here you can see that this collision is not being registered properly, even though it should. Right, just like here. Not sure why. Let me check. But yeah, basically this should be it. Let me check if the values are correct. I believe for the right side, yes, we should be right to the edge. So this should be correct. Yeah, I believe that's actually it when it comes to our stopping and our movements. So I will see you in the next section where we'll handle the shooting and destroying the grid. See you there.